Hi my dear students, welcome back to the class. So far we were discussing about the three-dimensional geometry, isn't it? We discussed the angle between two lines. Also we discussed various formula to find the angle between two lines, etc. Also we discussed various concepts regarding direction ratios, direction cosines, etc. So in this class we are going to solve the exercise 11.2 of your textbook, and also note that if you have any doubt regarding the previous sessions, just go back to those lectures and watch it well. Only after that watch this lecture, because in this class we are going to solve all those problems which are related to the concepts we have discussed so far. So without any further intro, we shall move on to the class. The first question is question number 1. Show that the three lines with the direction cosines 12 by 13 minus 3 by 13, next one is minus 4 by 13. So this is the direction ratio of the first line, and the second line is nothing but 4 by 13 comma 12 by 13 comma 3 by 13. So this is the direction cosines of the second line, and the direction cosines of the third line is given by 3 by 13 minus 4 by 13 and 12 by 13. We have to show that these three lines are, so these are the three direction cosines of those respective lines, and we have to show that these three lines are mutually perpendicular. So in order to show that these three lines are mutually perpendicular, we have to show that the angle between these three lines is equal to 0. See, we have to show that these are mutually perpendicular, which means that this line and this line are perpendicular, these two lines are perpendicular. Again we have to show that the first line and the third line are also perpendicular. See, so that's it. So in order to show that they are perpendicular, we need to show that the angle between these lines are equal to 90 degree, or cos 90 is equal to 0. We know that the angle between the lines cos theta is given by L1 L2 plus M1 M2 plus N1 N2, where L1 M1 N1 are the direction cosines of the first line, L2 M2 N2 are the direction cosines of the second line, isn't it? So in order to find the angle between these two lines, it is enough to show that cos theta is equal to 0, then theta will become 90 degree. We shall check it out. It is equal to L1 into L2, it is equal to 12 by 13 into 4 by 13 plus M1 into M2, it is equal to minus 3 by 13 into 12 by 13 plus minus 4 by 13 into 3 by 13 minus 4 by 13 into 3 by 13, isn't it? Now 12 into 4 is nothing but 48, 13 into 13 is nothing but 169 plus minus 3 into 12 is nothing but minus 36 divided by 169 minus 4 into 3 is nothing but 12 by 169. See, 48 minus 48, it will become 48 by 169 minus 48 by 169, which is equal to 0, which means that the angle between the first and the second line is nothing but 90 degrees, since cos 90 degree can only be 0. So the angle between cos theta is nothing but 0, which means that theta is equal to 90 degree, isn't it? Which means that the first and the second line is perpendicular to each other. In a similar manner, you can show that the second and the third line is perpendicular to each other, and at the last it is easier for you to show that the first and third line is perpendicular to each other. Just apply the formula for cos theta is equal to L1 L2 plus M1 M2 plus N2 M1 N2, which is the formula to find the angle between the two lines when the direction cosines are given. Now we shall move on to the next question. Now coming on to the question number 2. Question number 2 is that show that the line through the points 1 minus 1 2 1 minus 1 2 and 3 4 minus 2. The line through the points 1 minus 1 2 and 3 4 minus 2 is perpendicular through the line through the points 0 3 2 and 3 5 6. We shall name this as C and D. So this is the point A, this is the point B, this is the point C, and this is the point D. First of all, we shall find the direction ratios of the line AB and the direction ratios of the line CD, just like this. The direction ratios of AB can be obtained by the first component is 3 minus 1, which is 2. The second component is 4 minus minus 1, which is 5. And the third component is minus 2 minus minus 2. Sorry, minus 2 minus 2, which is minus 4. So this is the direction ratios of the line AB. Now we shall find the direction ratios of the line CD. 3 minus 0, which is 3. 5 minus 3, which is 2. 6 minus 2, which is 4. So these are the direction ratios of the line CD. So in order to show that these two lines are perpendicular, we know that whenever we have A1, A2, A3 and B1, B2, B3 are the direction ratios, then cos theta is nothing but, what is cos theta? Modulus of A1, B1 plus A2, B2 plus A3, B3 whole divided by square root of A1 square plus A2 square plus A3 square into B1 square plus B2 square plus B3 square, isn't it? So this is the cos theta when the A1, A2, A3, B1, B2, B3 are the respective direction ratios of the line segment. Now we shall find, see, we have to show that these two lines are perpendicular, which means that cos theta is equal to 0. When will cos theta equal to 0? The denominator equal to 0. So in order to check whether these two lines are perpendicular or not, it is enough for us to check whether this numerator is equal to 0 or not, which means that here our A1 is this, A2 is this, A3 is this, B1 is this, B2 is this, B3 is this. So in order to check whether these two lines are perpendicular or not, this numerator must be equal to 0, which means that A1 B1, so 2 into 3 equal to 6 plus A2 B2, 5 into 2 is equal to 10 minus 4 into 4 equal to 16 equal to 0 or not. We have to check whether it is 0 or not. 10 plus 6 equal to 16 minus 16 equal to 0, which means that the angle between these two lines is nothing but 90 degree, since cos theta is equal to 0 here. So we can say that these two lines are mutually perpendicular. Now we shall go to the third question of this exercise. Coming on to the question number 3, show that the line through the points 4, 7, 8, this is the first point, and the second point is 2, 3, 4 is parallel to the line through the points minus 1, 2, 1, sorry, minus 1, minus 2, 1 and 1, 2, 5. Show that the line through the points, these 2 points is parallel to the line through the points, these 2 points. So this is the point A, B, C and D. So first of all, we have to find the direction ratios of AB. This is very simple for you now. 2 minus 4 is minus 2, 3 minus 7 is minus 4. Now 4 minus 8 is again minus 4. This is the direction ratios of the first line AB. Now the direction ratios of CD is equal to 1 minus minus 1 is equal to 2, 2 minus minus 2 is equal to 4, 5 minus 1 is equal to 4 again. So this is our A1, this is our A2, B1, B2, C1, C2, let it be. So in order to show that these two lines are parallel, we have derived a condition in the previous class. If A1, B1, C1 are the direction ratios of the first line and A2, B2, C2 are the direction ratios of the second line, then they are parallel if and only if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, isn't it? Now we shall check whether this relation is valid here or not. A1 by A2, what is it? Minus 2 by 2 is equal to minus 1. B1 by B2 is equal to minus 4 by 4 equal to again minus 1 equal to C1 by C2 again minus 4 by 4 equal to minus 1, which means that here A1 by A2 is equal to B1 by B2 is equal to C1 by C2, which means that these two lines are parallel by this condition. Now we shall move to the question number 4 of this session. Question number 4 is a very simple question. The question is that find the equation of the line which passes through the point 1, 2, 3 and parallel to the vector 3i plus 2j minus 2k cap. So we are given with an equation of the line. We have to find the equation of the line which passes through this point and parallel to this vector. We know the equation of the line which passes through the point A and parallel to the vector B as R is equal to A plus lambda B, where A is the position vector of the point on the line and B is the vector parallel to the line through that point, isn't it? Now, we know that this point A as 1, 2, 3. Then the position vector, small vector A is nothing but the position vector of the point A, which is equal to I cap plus 2j cap plus 3k cap, isn't it? I cap plus 2j cap plus 3k cap. See, here the coefficients are nothing but the points here. Since OA is nothing but 1 minus 0 I cap plus 2 minus 0 j cap plus 3 minus 0 k cap, isn't it? That's why we got the position vector of A as this, and that is named as small vector A. And also vector B is nothing but given as 3i cap plus 2j cap minus 2k cap. Therefore, the equation of the line which passes through this point and parallel to the vector B is given by R is equal to I cap plus 2j cap plus 3k cap. See, this is our formula. R is equal to A plus lambda B. So, A plus lambda into B is nothing but 3i cap plus 2j cap minus 2k cap. So, this will be the equation of the line which passes through the point A and parallel to the vector B. Now, we shall move to the fifth question. This question was very simple, but remember that here the point is on the line and we have to find the position vector of that point, and B is the line or vector parallel to that line or point. Now we shall move to the next question. Coming on to the question number 5. The question number 5 is find the equation of the line in vector and in Cartesian form that passes through the point with positive vector 2i minus, the vector is position vector 2i minus j plus 4k cap. So the line passes through the point whose position vector is given by this. This is the position vector. So we shall call it by the name small letter A. Now, and in the direction of I plus 2j minus k cap. See, this is given that it is in the direction of this vector, which means that the line is parallel to this vector. So we shall name this as vector B. So we are given with a vector whose position vector is this, and this point is in the line, as well as this vector is nothing but a vector which is parallel to this line. Now we have to find the vector as well as the Cartesian equation of this line. We know that the vector equation is given by R is equal to A plus lambda B. This is very simple and this was our previous problem. Now we shall easily find this. A is nothing but 2i minus j plus 4k cap plus lambda into B is nothing but I cap plus 2j cap minus k cap, isn't it? Now this is the vector equation. Of course, this is enough to be a vector equation of the line. Now we have to find the Cartesian equation. For that, follow these steps. These steps are very important to solve out these kinds of problems. Just name R as nothing but xi cap plus yj cap plus zk cap, which means that we have given variable value for R. We are giving variable values in order to get an equation as an output. So in order to get a Cartesian equation as output, we are renaming R as this. And since R is the position vector of an arbitrary point x, y, z on the line, please remember the process of derivation we have done in the previous class. So we have xi cap plus yj cap plus zk cap. It is equal to, now I am going to associate these entire right hand side in the terms of I cap, j cap and k cap. See, first term is nothing but 2 plus lambda I cap. 2i cap plus lambda I cap, which means 2 plus lambda I cap. Plus minus 1 plus 2 lambda j cap, isn't it? Minus 1 plus 2 lambda j cap plus 4 minus lambda k cap. So this is the reduced form of the right hand side. Now we shall equate the LHS and RHS with respect to the respective components. Here the component of I cap is nothing but x, and here the component of I cap is nothing but 2 plus lambda. And next one is y minus 1 plus 2 lambda. And the third one is nothing but z is equal to 4 minus lambda. Now we shall equate for lambda. So it will become x minus 2 by 1 is equal to lambda. Next one is y plus 1 divided by 2 is equal to lambda. And in the last one, z minus 4 divided by minus 1 equal to lambda. Right. Now see, every equation has RHS is nothing but lambda, so we can eliminate this RHS and equate all these things together to get the Cartesian equation. X minus 2 by 1 equal to y plus 1 by 2 is equal to z minus 4 by minus 1. See, what we have done here is all equation are equal lambda equal. So we can equate all the left hand sides together to get the Cartesian equation of the line segment. Now we shall move to the next question. So coming on to the question number 6, the question number 6 says that find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the line segment x plus 3 divided by 3 is equal to y minus 4 divided by 5 is equal to z plus 8 divided by 6. So we have to find the Cartesian equation of the line which passes through this point and parallel to this vector. See, here from this line segment itself we can obtain the direction ratios of, we shall name this line as AB, the direction ratios of AB as 3, 5 and 6. Since this line is parallel to the line which passes through this point, we can always say that the direction ratios of, we can name this as a point say D. So the direction ratios of the line passes through D is equal to again 3, 5, 6. Why? Because this line is just line is parallel to the line which passes through D. Hence we can say that the direction ratios of this line segment 3, 5, 6 will be the direction ratios of the line segment D. See, we know that a line can have infinitely many direction ratios. So basically the direction ratios of the line which passes through the point D is of the form 3k, 5k and 6k, so that these and this, the direction ratios of this line and the direction ratios of this line will be proportional, so that 3k by 3k, 3 is nothing but k, 5k by 5 is nothing but k, 6k by 6 is nothing but k. Hence we can say that these two lines are parallel. So in particular, when k is equal to 1, we get the direction ratios of the line which passes through the point D as nothing but 3, 5 and 6. Also we know that the line passes through the point minus 2, 4, minus 5. Hence we know that the equation of the line which passes through a particular point and having direction ratios as this as equal to x minus x1 by a1 equal to y minus y1 by b1 is equal to z minus z1 by c1, where a1, b1, c1 are the direction ratios, x1, y1, z1 are the points by which the line passes. Hence substituting these values we get x minus x1 is nothing but minus 2. So x plus 2 by a1 is nothing but 3 is equal to y minus y1 is nothing but 4. Y minus 4 divided by the direction ratio is equal to 5. And then z minus z1 is nothing but minus 5. So it will become z plus 5 divided by the direction ratio is nothing but 6. So this will be the Cartesian equation of the line which passes through this point and parallel to the vector. Now, you will explain this line direction ratios in 3, 5, 6. This line direction ratios are parallel. Parallel direction ratios respective components proportional. Now, this direction ratios is possibility 3k, 5k, 6k. This is proportional. This is proportional. This is proportional. Where k is constant. I am particular k 1 k 2 is valid. K 3 same equation equation of this line. So that doesn't matter, whatever will be the value of k, you will get an equation like this, which is the equation of the line which passes through the point D. Now we shall move to the next question. The Cartesian equation of a line, the question number 7 is that the Cartesian equation of a line is x minus 5 by 3 is equal to y plus 4 by 7. It is equal to z minus 6 by 2, isn't it? This is the Cartesian equation of a line. So we have to find its vector form. This is a very simple question. So we have to find the vector form of this equation. From this equation itself, it is clear that the line passes through the points 5, minus 4, 6. Right, the line passes through. See, x minus 5 is our standard form is nothing but x minus x1 by a 1 equal to y minus y1 by b1 is equal to z minus z1 by c1. Don't remember the standard form, so that we can easily calculate the points by which the line passes. Here given y plus 4, actually this is nothing but y minus 4. That's why I taken minus 4 as the point, as the coordinate of the point. Now this is the point by which the line passes. Also the direction ratios of the line parallel to the given line is equal to, what is the direction ratios? 3, 7, 2, which is evident from the equation. See, a1, b1, c1 are the direction ratios of the line or vector which is parallel to the line which passes through the given point. That was our condition in the derivation of this Cartesian equation, isn't it? So we can take the direction ratios are 3, 7, 2. Now if this is the point A, we can derive vector A as the position vector of the point A, which is equal to 5i cap minus 4j cap plus 6k cap, isn't it? Now direction ratios of the line parallel to the given line is given by 3, 7, 2. So the vector equation, vector form of the same line is equal to 3i cap plus 7j cap plus 2k cap. Note that if we are given with the direction ratios of a line, we can easily derive the vector equation of the line is just by giving I cap plus j cap plus k cap to the respective direction ratios. So we get the vector B also. Now it is very simple. The vector equation R is equal to vector A plus lambda into vector B, which is equal to 5i cap minus 4j cap plus 6k cap plus lambda into, what is B? 3i cap plus 7j cap plus 2k cap. So this is the vector equation of the line which passes through the point 5, minus 4, 6 and with direction ratios 3, 7, 2. We shall move to the next question. Now question number 8 is an extremely simple question. The question is that find the vector and Cartesian equation of the line that passes through the origin and the point 5, minus 2, 3. So we have to find the vector as well as the Cartesian equation of a line which passes through the point origin and through the point this. See, here we are given with 2 points. Now this condition is very special, just concentrate on it. Here we are given that the line passes through both these points. In particular, the line passes through the point origin. So we can say that A is equal to, always remember that whenever we are asked to find the vector equation of a line which passes through a point and parallel to another vector, the equation is nothing but R is equal to A plus lambda B, where A is the position vector of the point through which the line passes and B is the vector which is parallel to the line segment. Just remember that. Now, since the line passes through the point origin, we can say that A is nothing but 0i cap plus 0j cap plus 0k cap. Just let it be there. Now, since the line passes through this point also, see, the line passes through these 2 points also, we can say that this line is parallel to the vector connecting these 2 points. Why? Always remember that a vector or a line is parallel to itself, which means that we need a vector which is parallel to the given line segment. We are taking the original line as the line which is parallel to the given line. So B can be chosen as the vector connecting these 2 points, since the vector connecting these 2 points will be parallel to the line through this point. So the vector connecting these 2 points is nothing but 5i cap minus 2j cap plus 3k cap. So now it is very simple. R is nothing but A plus 0 plus lambda into, what is B? 5i cap minus 2j cap plus 3k cap, isn't it? Now always remember that this 0 is nothing but 0i cap plus 0j cap plus 0k cap. Now we want the Cartesian equation, just like before we renaming x as r as xi cap plus yj cap plus zk cap. It is equal to vector 0 plus lambda into 5i cap minus 2j cap plus 3k cap, isn't it? Now we can equate the respective components, which gives us x minus 0 divided by 5 is equal to y minus 0 divided by minus 2 is equal to z minus 0 divided by 3, which is the Cartesian equation. How you know how we can obtain this? See, the first component is nothing but x is equal to, here we have as I cap, the coefficient of I cap is 0. 0 plus lambda into 5 as the coefficient of I cap, right? Now we want lambda, which means that x minus 0 divided by 5 is equal to lambda. Similarly, we can obtain y minus 0 by minus 2 is equal to lambda. Z minus 0 by 3 is equal to lambda. Since all these quantities are equal to lambda, we can equate all these left hand sides to get the Cartesian equation. So this is as simple as that. Now we can move to the next question, question number 9 of your textbook. Question number 9 is that find the vector and Cartesian equation of the line that passes through the point 3 minus 2 minus 5 and 3 minus 2 6. So we have to find the vector and Cartesian equation of the line which passes through the point 3 minus 2 minus 5 and 3 minus 2 6, isn't it? In the similar way we can do the this problem is just similar to the previous problem. We are given with 2 points, not a vector parallel to the line or a point which passes or the point which is in the line. So here we have to do the same exact steps in the previous problem. See, whenever we are given with a point on the line and a vector parallel to the line, we can do the line vector equation of the line is nothing but a plus lambda v, where a is the position vector of the point and b is the vector parallel to it. Okay. Now since this point, let me name this as p and q, this as pq. So the line is nothing but pq. Okay. Now since we know that PQ, the line PQ passes through this point, we can choose A as the position vector of this point. So A is nothing but 3i cap minus 2j cap minus 5k cap. This is the point A. Okay. Now we want the vector B. B is the vector which is parallel to the line PQ. Always note that the vector joining the point P and Q will be parallel to the line PQ itself. So we can choose B as 3 minus 3i cap, which is 0i cap, minus 2 minus minus 2j cap, minus 2 plus 2j cap, which is 0j cap. Now 6 minus minus 5k cap, which is plus 11k cap. So this is the vector B. Hence we have R is equal to A plus, what is A? 3i cap minus 2j cap minus 5k cap, A plus lambda into, what is B? 0i cap plus 0j cap plus 11k cap, that is 0i cap plus 0j cap plus 11k cap. So this is the vector equation of the line which is passes through these 2 points. It is easier for us to derive the Cartesian equation. Just do this. Xi cap, R is nothing but xi cap plus yj cap plus zk cap, which is equal to 3i cap minus 2j cap minus 5k cap plus lambda into 0i cap plus 0j cap plus 11k cap. Now we can equate the corresponding components on left side and right side respectively. So that will become x minus 3 divided by 0 is equal to y plus 2 divided by 0 is equal to z plus 5 divided by 11. This will be the vector equation, the Cartesian equation of the line which passes through these 2 points. Now we shall move to the next question. Coming on to question number 10. Find the angle between the following pairs of line. You are given with 2 pairs of line The first one is r is equal to 2i cap minus 5j cap plus k cap plus lambda into 3i cap minus 2j cap plus 6k cap. This is the first line, and the second one is nothing but r is equal to 7i cap minus 6k cap plus mu into I cap plus 2j cap plus 2k cap. So this is the first pair of line, so that we have to find the angle between these two lines. It is very simple. We know that if r is equal to a1 plus lambda b1 and r is equal to a2 plus mu b2 are the two lines, then we can easily find the angle between these two lines using the formula cos theta is equal to absolute value of b1 b2, b1 dot b2 divided by mod b1 into mod b2. Do you remember this formula? See, here we know that b1 and b2 are parallel to these two lines. So in order to find angle between these two lines, it is enough to find the angle between b1 and b2, and using the formula for cross dot product, we can easily find the angle cos theta between these two lines, isn't it? Now we shall find b1 dot b2. It is equal to, here vector b is equal to this, and here vector b is equal to this vector. b1 dot b2 is equal to 3 into 1 equal to 3 plus minus 2 into 2, it is equal to minus 4 plus 6 into 2 is equal to 12, isn't it? So we got b1 dot b2 is nothing but 3 into 1 3 minus 2 into 2 minus 4, so 6 into 2 12, so it is equal to minus 1 plus 12 is equal to plus 11. So we get b1 dot b2 as 11. Now mod b1 is equal to square root of, what is mod b1? 3 square is 9 plus 2 square is 4 plus 6 square is 36. So 36 plus 9 equal to 45 plus 4 is equal to 49. Square root of 49 is nothing but 7. Now mod b2 is equal to, mod b2 is nothing but what? Okay, square root of 1 square is equal to 1 plus 2 square equal to 4 plus 2 square equal to 4, which is equal to root 9, which is equal to 3. Now we get cos theta, the angle between these two vectors, as modulus of 11 divided by mod b1 into mod b2, it is equal to 21. So mod 11 by 21 will be, so cos theta is nothing but 11 by 21, as this quantity is positive. So theta is equal to cos inverse, 11 by 21 will be the angle between these two lines. Similarly, you are given with a second pair of line, which is r is equal to 3i cap plus j cap minus 2k cap plus lambda into I minus j plus minus 2k cap, and r is equal to 2i cap minus j cap minus 56k cap plus mu into 3i cap minus 5j cap minus 4k cap. This question is also very simple question. You can do the same question just using the same method to find the angle between two lines, and you will get the angle between these two lines as cos theta is equal to 8 by 5 root 3. So you will get the angle between these two lines as cos theta is equal to 8 by 5 root 3 on solving the entire equation by using this process. So you can easily find cos theta. So we shall move on to the next question. Now coming on to question number 11, this is also very similar to question number 10. Here we are given with find the angle between the following pairs of line, and you are given with a pair of line in Cartesian form. So you have to find the angle between these two lines. The first question is, in the question number 11, the first subpart is, the lines given are x minus 2 by 2 is equal to y minus 1 by 5 is equal to z plus 3 by minus 3. And the second line is nothing but x plus 2 by minus 1, y equal to y minus 4 divided by 8 is equal to z minus 5 by 4. So this is question number 1 of first subpart of question number 11. So from here we know that the direction ratios of the vector which is parallel to the first and second line is given by direction ratios of vector v1, let it be b1 be the first vector which is parallel to the first line, is given by 2 5 minus 3, and the direction ratios of vector b2 is given by minus 1, 8, 4, where b1 is the vector which is parallel to this line and b2 is the vector which is parallel to this line. Okay, now we can find the angle between cos theta is nothing but the angle between these two lines, which is also the same as the angle between two parallel vectors. So we can find the angle between these two vectors. It is equal to modulus of b1 dot b2 divided by mod b1 dot mod b2, isn't it? It is equal to, we have b1 dot b2 is equal to 2 into minus 1 equal to minus 2 plus 5 into 8 is equal to 40 plus minus 3 into 4 is equal to minus 12. So minus 40 minus 14, right? So the answer is 26. So b1 dot b2 is equal to 26. Now we have mod b1 is equal to, mod b1 is equal to square root of 4 plus 25 plus 9. It is equal to root of 38. Mod b2 is equal to square root of 1 plus 64 plus 16 is equal to root of 81 is equal to 9. Therefore, cos theta is equal to modulus of b1 dot b2. It is equal to 26 divided by mod b1 mod b2, 9 root 38. So this will be the cos theta, the angle between these two lines. So this is very simple question. Just identify the direction ratios of the parallel vectors, then it is very simple to solve. Also here is a second part for you. You can solve this also very easily. Just identify the direction ratios of the parallel vectors. So you can easily identify the second answer for the second question also by using a similar method. Now we shall move to the question number 12 of your textbook. Question number 12 is, find the value of the p so that the line 1 minus x divided by 3 is equal to 7y minus 14 divided by 2p is equal to z minus 3 divided by 2, and the second line is 7 minus 7x divided by 3p equal to y minus 5 divided by 1 is equal to 6 minus z by 5 are at right angles. This is very simple. We know that how to find the angle between the two line segment which is given in the Cartesian form. First of all, we have to identify the vector, the direction ratios of the lines which are parallel to these vectors. So we can identify b1 and b1 and b2 as the where b1 is the vector which is parallel to this and b2 is the vector which is parallel to this. Then we do cos theta is equal to what? Mod b1 b2 divided by mod b1 into mod b2, isn't it? This was our formula. So in order to these two lines to be perpendicular, this must be equal to 0, which is only possible if b1 dot b2 is equal to 0, which can be only possible if the corresponding product of the direction ratio is equal to 0, right? So we have to find the direction ratios of the vectors which are parallel to these two lines and then equate the product to 0. Okay, that's our strategy. Now first of all, before operating or before identifying this as the direction ratio, this as the second direction ratio and this as the third direction ratio of the first line, just convert the given equation to the standard form. Our equation standard form is nothing but x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. This is the standard form of our equation, isn't it? So before operating the line or before operating the equation, we have to convert this into the standard form. So converting this into the standard form, the equation will become x minus 1 divided by minus 3. We have to multiply the numerator and the denominator with respect to minus 3 so that this will become this form. Now here we have 7 by minus 14 divided by 2p, right? We can take 7 common, so it will become y minus 7, y minus 2 divided by 2p. This will be y minus 2 divided by 2p by 7. So this is of the form y minus y1 by b1, right? So we have y minus 2 divided by 2p by 7 as the second component. It is equal to, now the third component is z minus 3 by 2, which is in the standard form itself, and the second line. Here we can take, first of all we have to multiply the numerator and the denominator with respect to -1 so that x comes first. So it will become 7x minus 7 divided by minus 3p, right? Now we can take 7 common. So 7 into x minus 1 divided by minus 3p. So it will become x minus 1 divided by minus 3p by 7. So that this will be in this form, x minus x1 by a1. So the first equation is, first component is of the form x minus 1 divided by minus 3p by 7, which is equal to y minus 5 by 1, which is equal to z minus 6 by minus 5. We have to multiply the numerator and the denominator with minus sign, so that will be in the standard form. Now we have the things in the standard form. Now it is very easy. The direction ratios of the first vector b1 is equal to minus 3, 2p by 7, 2, isn't it? And the direction ratios of second component, direction ratios of second component b2 is nothing but minus 3p by 7, 1, minus 5, isn't it? Now we can easily find the angle between, the value of p, just finding the angle between these two line segment just by evaluating cos theta. Cos theta is given by b1 dot b2 by mod b1 b2. Now since these are to be in right angles, our condition is what is the value of p when these two lines are in right angles, so that b1 dot b2 must be equal to 0, which means that the dot product is equal to 0, which is equal to minus 3 into minus 3p by 7 plus 2p by 7 into 1, 2p by 7 into 1 plus 2 into minus 5, 2 into minus 5 is equal to 0. So this is equal to 9p by 7 plus 2p by 7 is equal to 2 into minus 5 equal to minus 10. When it goes to right side, it will become 10. So it is equal to 9p plus 2p equal to 70. So 11p is equal to 70. Therefore p is equal to 70 by 11. So this is as simple as that. Just make it into a standard form, then use the formula for finding the angle between two lines, given that these two are in right angles, so the numerator must be equal to 0. So deriving this condition, we get the value of p. Now question number 30 is that show that the lines x minus 5 divided by 7 is equal to y plus 2 divided by minus 5 is equal to z by 1 and x by 1 equal to y by 2 is equal to z by 3 are mutually perpendicular. So we have to show that these two lines are very perpendicular. So easily we can find these things. This is a very simple problem, just like the previous problems. Direction ratios of b1, vector b1 and vector b2. Note that here I am denoting b1 and b2 as the vectors which are parallel to this line and this line respectively. Also we note that the denominators are the direction ratios of the parallel vectors. So we have direction ratios of b1 is nothing but 7 minus 5 1. The direction ratios of the vector b2 is nothing but 1 2 3. So in order to show that these two lines are mutually perpendicular, we can show that b1 dot b2 is equal to 0. b1 dot b2, evaluating b1 dot b2, it is equal to 7 into 1 equal to 7 minus 5 into 2 equal to minus 10 plus 1 into 3 equal to 3, isn't it? Now 7 plus 3 equal to 10, it is equal to 0. Which means that b1 dot b2 is equal to 0. See, cos theta is nothing but mod b1 dot b2 divided by mod b1 dot mod b2. Since the numerator is equal to 0, cos theta is equal to 0, which means that theta is equal to 90 degree, which means that these two lines are perpendiculars. That's it. Question number 30, very simple question. We shall move to question number 14. Now coming on to question number 14. The question number 14 is that find the shortest distance between two lines, where first line is given by r is equal to I cap plus 2j cap plus k cap plus lambda into I cap minus j cap plus k cap, and the second line r is equal to 2i cap minus j cap plus k cap plus mu into 2i cap plus j cap plus 2k cap. So these are our two lines. So we have to find the shortest distance between these two lines. So we know that whenever we are given with two lines, r is equal to a1 plus lambda b1 and r is equal to a2 plus mu b2. The shortest distance d between these two lines is given by absolute value of b1 cross b2 dot a2 minus a1 divided by mod b1 cross b2. Do you remember this result? Using this result, we can find the shortest distance between these two lines. Now we shall evaluate each component in particular. First of all, we are going to find b1 cross b2. It is equal to I cap, j cap, k cap. Determinant. Now the components of first b1 is equal to I minus 1 1 1 minus 1 1 and the second components of the second vector is 2 1 2 2 1 2. So b1 cross b2 is equal to I into minus 2 minus 1 minus j into 2 minus 2 0 plus k into 1 minus minus 2, it is equal to 3. So it will become minus 3i cap plus 0 j cap plus 3k cap. Now a2 minus a1. a2 minus a1 is equal to, what is a2 this? a1 this. 2 minus 1 equal to I cap minus 1 minus 2 minus 3j cap minus 1 minus 1 minus 2k cap. Therefore a2 minus a1 dot b1 cross b2, it is equal to minus 3 into 1 minus 3, 0 into minus 3 plus 0, 3 into minus 2 equal to minus 6 equal to minus 9. Now mod b1 cross b2, square root of, what is b1 cross b2? This is the b1 cross b2. So it will become 9 plus 9. It is 2 root 3, right? Sorry, 2 root, it is equal to 18, it is equal to 3 root 2. Therefore, d is equal to absolute value of minus 9 divided by 3 root 2. It is equal to, see, we have just substituted these things into this formula. It is equal to absolute value of minus 9. We can cancel 3 and 3 here. So it will become 3 by root 2. So it is equal to 3 by root 2. Now we can multiply numerator and denominator with respect to root 2. So it will become 3 root 2 divided by 2. So the shortest distance between these two lines is nothing but 3 root 2 by 2. Now we shall move to the question number 15 of this session. Moving on to the 15th question of your textbook. The 15th question is that find the shortest distance between these two lines. Note that these two lines are given in the Cartesian equation form. Right? So we need to apply the Cartesian equation to find the shortest distance. This is the Cartesian equation. We have learned the process of derivation of this equation in the previous class. If you have any doubt, go back to that lecture and watch it well. So this is the equation of the Cartesian equation of the shortest distance between two lines which are given in the Cartesian form. This is very important equation, so by heart it well, and from this equation we can directly substitute the things. We can just write the required things. We have x1 is equal to, we know that the standard form is x minus x1 divided by a1, right? X minus x1, but here it is of the form x plus 1. We can separate it as x minus minus 1, right? So x1 is nothing but minus 1, y1 is nothing but minus 1, z1 is nothing but 3, sorry, minus 1 again, right? Minus 1. x2 is equal to 3, y2 is equal to 5, z2 is equal to 2, right? Sorry, 7, this is 7. So z2 is equal to 7. Again, a1 is equal to 7, a2 is equal to, sorry, b1 is equal to minus 6 and c1 is equal to 1. a2 is equal to 1, b2 is equal to minus 2, c2 is equal to 1. Now we know that A1, B1, C1 are the direction ratios of the line which is parallel to this line segment. Similarly, these 2 or 3 are the 1 minus 2, 1 is the direction ratios of the vector which is parallel to the second line. So we got all the required things, isn't it? We can just substitute those two values in the formula for to find the shortest distance. X2 minus X1 is equal to 3 minus minus 1, 4. y2 minus y1, 5 minus minus 1 is equal to 6. നിങ്ങൾ ഇതുപോലെ സാധനങ്ങൾ ലിസ്റ്റ് ചെയ്തിട്ട് എഴുതുവാണെങ്കിൽ എളുപ്പമുണ്ട് കേട്ടോ, തെറ്റിപ്പോകത്തില്ല. z2 minus z1, 7 minus minus 1 is equal to 8. So we get first row. Second row, a1, b1, c1 which is 7, 6, 1. a2, b2, c2 which is 1, minus 2, minus 2, c2 is 1. So on evaluating this denominator, our next objective, we evaluated the numerator and now our next objective is to evaluate this denominator. See, here we have to find b1 c2 minus b2 c1 where all the quantities are provided here. So it is easier for us to find this. On evaluating the entire quantity, we get this equal to square root of 116. So the denominator is equal to square root of 116. So this will be d is equal to minus 116 divided by square root of 116. It is equal to absolute value of c. Here we have to take the positive value only, so that it will become 116 divided by square root of 116 equal to root 116 equal to square root of 4 into 29 is equal to 2 root 29 will be the shortest distance between these two lines. So that's the end of question number 15, and now we shall move to the question number 16 of your textbook. Now coming on to question number 16. Question number 16 is that find the shortest between two lines whose vector equations are. We are given with two lines whose vector equations are given by I cap plus 2j cap plus 3k cap plus lambda into I cap minus 3j cap plus 2k cap. And the second vector whose vector equations are 4i cap plus 5j cap plus 6k cap plus mu into 2i cap plus 3j cap plus k cap. So this is the two vector equations of the lines. We have to find the shortest distance. Very easy for you now. We know the formulas. D is equal to b1 cross b2 dot a2 minus a1 divided by mod b1 cross b2. We have done a similar problem before in the, I think it is question number 14. So it is easier for you to calculate these things, since b1 is this vector, b2 is this vector, a1 is this vector and a2 is this vector. Very easy, just substitute these values and find the answer, and the final answer of this question is 3 by root 19 units. So it is very easy for you to evaluate this answer. Just go through it. Now we shall move to the question number 17, which is the last question of this session. Going to question number 17, it is also a question to evaluate the shortest distance. The equations given us r is equal to 1 minus t I cap plus t minus 2 j cap plus 3 minus 2t k cap. So this is the first equation, and the second equation is r is equal to s plus 1 I cap plus 2s minus 1 j cap minus 2s plus 1 k cap. So this is the second equation. So we have to find the shortest distance between these two vectors. Now think that this form is a new format for you. We have to convert this form into the standard form. We know that the standard form is nothing but a1 plus lambda b1 and r is equal to a2 plus lambda b2. And if this is the case, it is easier for us to find the shortest distance as b1 cross b2 dot a2 minus a1 divided by mod b1 cross b2, isn't it? So it is easier if the format is this. So we have to convert the equations into this format. a1 plus lambda b1, a2 plus lambda b2, or whatever, lambda is a scalar, mu b2 or whatever it is. See, here the scalars are respectively s and t. So instead of lambda and mu, we can convert this equation of the form a1 plus s b1, a2 plus t b2. We shall check it out. First of all, we have to convert. We have to associate all the terms which does not have t in the first equation. See, r is equal to, here we have 1, here we have minus 2, here we have 3. So 1 I cap minus 2 j cap plus 3 k cap will be a1 plus t into. Now we are going to find all the terms which is with the coefficient t. Here we have minus 1, here we have 1, here we have minus 2. So minus 1 I cap plus j cap minus 2 k cap will be our b1. Now coming on to the next vector. First of all, we have to associate everything with without s, right? 1 minus 1, again we have to take this minus inside, so that this will be plus minus minus, right? So associating all the terms without s, we get I cap minus j cap minus k cap plus s into. Now we are going to associate everything with the coefficient s. 1, 2, minus 2. I cap plus 2 j cap minus 2 k cap. See, here our equation is reduced to, this is a rearranged form of these given lines. So here what we have got is an equation of the form a1 plus sb1, a2 plus sb2, tb2. So the shortest distance between these two lines will also be evaluated using this formula. Very simple. Just evaluate b1 cross b2. What is b1? Here take this vector as b1, this as b2, this as a1 and this as a2. So you can find a2 minus a1, b1 cross b2, and the dot product of these two also modulus of b1 cross b2. So take the fraction that will be the shortest distance between these two lines. So that's the end of this this exercise 1, exercise 11.2. So do all these problems very carefully, because these problems are most probably asked questions in your exam. So do this with very care and take it as a serious challenge for you to do it by yourself. Now in the next class we are going to move on to more deeper into the session, and we will solve exercise 11.3 in the coming classes. So wait for it and study these sessions till this session very well before you attend the next class. So till the next class, bye bye.